Hi everyone, another quick video. This one was sent to me by Gatika. It basically concerns a question where you're given 3 points that lie on a circle and you're asked to find the equation of a circle. This is the way the question was worded. It says a triangle has vertices 1, 1, 2, 3 and 0, 5. Find the equation of the circumcircle. Well, I haven't looked up the phrase circumcircle in a dictionary. I think I've heard it once or twice, but that must mean these 3 points lie on the circumference of a circle. So this is the circumcircle here. Look, there's the point 1, 1, here's the point 2, 3, and here's the point 0, 5. I just used GeoGebra to check my answer actually on this, which is good advice basically. If you don't know the answer to a question, use GeoGebra or something like that to find it. Okay, so let's do it. Yeah, now it is possible definitely to do this question by taking the general equation of a circle, plugging in 1 and 1 in there, you'll have an equation involving a, b and r. Then do the same for 2 and 3, you'll generate a different equation involving a, b and r. Then do the same for 0 and 5, you'll generate a third equation involving a, b and r, and then to solve those equations simultaneously. I'm not going to do it like that, but that is a possible approach. I'm going to use circle theorem. So if I can first get rid of my circle, one second, I'm just going to change basically what the diagram looks like as if I don't know the answer. So let me just take a picture of that and paste it in here. Perfect. Okay, right. So this is what it looks like before. Basically, have you heard of the following circle theorem? I'm going to use a circle theorem basically to do this one. I've got rid of my other picture in. Damn, that's a shame. Maybe it was better with the other picture anyway. Let me just show you I know it includes the answer, but we can't see the values on it. And the key thing is we're just trying to find the equation of that circle, which is passing through all 3 points. Well, do you remember this circle theorem from GCSE, that if you ever have 2 points, if you find a perpendicular bisector through those 2 points, it must pass through the centre of the circle? Yeah? Great. That gives us a way we can find at least a line which includes the centre of the circle. Now you can do that with this point and this point actually as well. You could find the gradient of that, and therefore you could establish the perpendicular bisector, and where they intersect, that will be the equation of that will be the centre of the circle. Once you've got the centre, it'll be easy to find a radius, and so we'll be able to work everything out. So that's my strategy. Yeah. So all I'm going to do first is I'm going to write down 1 and 1, because I actually used 1 and 1 and 2 and 3 first. So I found AB, the AB line first, yeah? And then I used 2, 3 and 0, 5. So then I did that one and found that perpendicular bisector next. Okay, so that's what I'm going to do. Okay, so the gradient of the chord, so let me put m little c here, is change in y over change in x, which is 2 over 1, which is 2. And therefore the gradient of the perpendicular bisector is going to be the negative reciprocal of that, and so it's minus a half. Now, I should be using this one, and look at that, it doesn't look very much to scale, this, does it? Let me just try and improve that part of my diagram. Really quite poor. It should be looking more like that. Yeah, something like that. Okay, so that is the gradient of this line here, that minus a half. That is the gradient of that line, and I know that the midpoint also lies on this straight line, so I've got y equals, well, if you like, y minus y1 is m times x minus x1. M here is minus a half. Now I do need to find the midpoint. The midpoint of those 2 points is going to be 1.52, and so y minus 2 is minus a half times by x minus 1.5. Times it all by 2, you get 2y minus 4 is going to be minus x plus 3 over 2. I'm going to times it by 2 again. 4y plus 2x, I'm going to add that over as well and add this over. Remembering I've doubled everything, so that's going to be 3, that's going to be plus 8, that's going to give you 11. Yeah, I've done that quite quickly, I apologise, but I just wanted to get it done. I'm sure you can work through it and see for yourself why that is the final answer. Okay, exactly this. We now know, by the way, the equation of this line. That is the equation of that line there. Yeah, I now want to find the equation of this line over here. I'm going to start by finding the gradient of the chord, which is change in y over change in x, which is 2 over minus 2, which is minus 1. That's got a gradient of minus 1. So what's the perp gradient? The perpendicular gradient will be 1. Okay, I can now do y minus y1 is 1 times by x minus x1. But what's the midpoint? It's going to be 1. The middle of 3 and 5 is going to be 4. So you're going to have y minus 4 is 1 times x minus 1, or in other words, y equals x plus 3. And that's the equation of that line. Yeah, and you can see, look, it basically is. I've done it quite rough, but that's the equation of the line y equals x plus 3. What are we going to do next? We're going to find where those two lines meet. That's what we're going to do. And so I'm going to plug it in here. So 4 times by x plus 3 plus 2x equals 11. So 4x plus 12 plus 2x is 11. That's going to lead us to 6x is minus 1. And so x is minus 1/6. That's a shame. I was hoping for a nice answer. And if x is minus 1/6 and you add 3 to it, y will be 17 over 6. So we now know that our circle definitely is of this form. X plus 1/6 squared plus y minus 17 over 6 squared. Yeah? Equals r squared. Now how are we going to find the radius, or the square of the radius? Well, that's not too bad either. We now know that this is minus 1/6, 17 over 6, which looks right on my diagram. Minus 1/6, 17 over 6, 2 and a bit, almost 3. I'm going to find the distance from there to 0,5, yeah? So I'm finding the distance from minus 1/6, 17 over 6 to 0,5. Well, what do we have here? R squared is going to be equal to that minus that squared, which is 1/6 squared, which is 1 over 36, plus from here to here, well, 5 is like 30 over 6, minus 17 over 6 is like 13 over 6. But I'm going to be squaring it, so yeah, let me write it as 169 over 36. And so r squared is 170 over 36. You could square root that to find the radius, but we need the radius squared, so let's just write down the answer now. It's x plus 6 squared plus y minus 17 over 6 squared equals 170 over 36. Yeah. And I made sure I got it right because it is a tough question, that, and I made sure I got it right by drawing it on GeoGebra, and it seemed to pass through the 3 points in question. You could easily check it in the exam, of course, using a calculator. Plug that in there, it should be true. Plug that one in, it should be true. Plug this one in, it should be true. If all 3 points satisfy that equation, it's clearly the equation of a circle, and so it must be the equation of the circle which the 3 points lie on. Okay, hope that was useful. Keep up the hard work, and bye-bye.